Okay, so this is the second period video. We will do 19, 22, 25, 28. So number 19. Given f of x equals this piecewise function, evaluate the antiderivative from 1/2 to 5 of f of x dx. Okay, but I can't really go 1/2 to 5 because it's split up with 1. So this is that property that if I want to go from 1/2 to 5, I could go 1/2 to 1 and then 1 to 5. And not only could I do that, I have to do that, because from 1/2 to 1, see, that would be where x is less than 1. That's the 2x statement. And from 1 to 5, when x is bigger than 1, that would be 2. So it looks like one integral, but we kind of have to do two separate pieces because there's two pieces to the function. So 1/2 to 1 of 2x dx plus 1 to 5 of 2 dx. Okay, let's pause there. Do you understand how I split those up and why I split those up? All right, so now I've got two separate antiderivatives to work. And now I'm thinking, do I want to do an antiderivative or do I want to do area? Because they're both the same thing. I think for 2x, I think I want to do an antiderivative because it's an easy antiderivative. It's just x squared from 1/2 to 1. So that would be 1 minus 1/4. For the antiderivative of 2, or the area under 2, this one's a little easier to do area on, a lot easier to do area on. Well, easier than the first one to do area on. It's about equally easy whether you want to do an antiderivative or an area. I'm going to do area just because I did antiderivative on the first one, and I want to just keep reminding you that it's both of those things. So if you do antiderivative, that's fine. 2x, plug in 5 minus plug in 1. If you're like me and you want to think area under 2 from 1 to 5, well, that's going to be 8. Just a rectangle. So either way, on that one, easy enough to do antiderivative, easy enough to do area. So there's my answer. That's my safe stop answer. Obviously, that doesn't really match any of my options over there. So 9 minus 1/4. So one way would be to look and see which of my options is 1/4 short of 9, which looks like B. The other way would be to keep going and get a common denominator. 36/4 minus 1/4 would be 35/4. But the main deal with number 19 is realizing you got to split it up at 1. Because it's one function left of 1 and a different function right of 1. Good old College Board, like to squeeze two problems into one problem. Right, number 22. Function f is defined by square root x. Okay, this is calculator because I'm like, how am I going to take a antiderivative of this thing? Square root of x cubed plus 2. G is an antiderivative of f such that g of 3 equals 5. Okay, g is an antiderivative of f. Just trying to translate word for word what that's saying. G of 3 is 5, then g of 1. Okay, so this means the antiderivative of f is g of something minus g of something else, but it's talking about 3 and 1, so we'll use 1 and 3. calculator. Put all my calculators up. I could do this in the calculator. G of 3 is 5. We're looking for G of 1. So G of 1 is, I'm going to do the algebra first here. I'll move G of 1 to the left and then move the integral over. So G of 3 minus the integral from 1 to 3 of f of x dx. So that is 5 minus whatever my calculator tells me. So negative 1.58, answer choice B. Again, the test is all no calculator, but when we get later on, we need to know where Math 9 is on the calculator so we can let the calculator do the hard work for us. Okay, so number 25. Suppose that 5x cubed plus 40 equals the antiderivative from c to x of f of t dt. Find the value of, or what is f of x? Okay, so the antiderivative is 5x cubed plus 40. Antiderivative is 5x cubed plus 40. So let's see. So if I take the derivative of this thing, right, that would tell me what f of x is. Or I could kind of write it like this. If I take the derivative of both sides, I would get 15x squared plus 0 equals f of x. Where did that 40 come from? Let's see. Find the value of c. I think those are related things here. You know what? Let's back up. If I want the antiderivative of 15x squared, that would be, let's see, that would be 5x cubed from c to x. Oh, and now I'm finding c. So if I plug in x, I get 5x cubed. If I plug in c, I get minus 5c cubed. And that is supposed to equal 5x cubed plus 40. So the 5x cubes are good, but this is where the 40 is going to come from. Negative 5c cubed is supposed to equal 40. So c cubed is negative 8, which means c is negative 2. Ooh, that's kind of a yucky one. Although part A wasn't too bad, part C, that was a little bit tricky. Number 28. Oh, here we go. This is one of our free response questions. Right? There's two free response questions. There's one from a table and one from a graph. So here's our from a graph question. The graph of a function. So here's our function f, consists of a semicircle and two line segments. G is equal to the antiderivative from 1 to x f of t dt. Okay, find g of negative 3. So g of negative 3 means, right, g of x means whatever's in parentheses goes in for x on the other side. So g of negative 3 is the integral from 1 to negative 3 f of t dt. right away there's something I kind of don't like about that particular problem. Let's flip it. Yeah, I don't want to go from 1 to -3. That's backwards. And to flip, or to change the backwards, let's flip the limits, but put a negative sign out front. So now this means the area under the graph from -3 to 1. So that's a half of a circle. Circle of radius 2. So pi r squared would be pi times 4. So half of that would be 2 pi. So I'm going to label that in case I need it later. So that half a circle is 2 pi. So that means, whoa, I messed something up here. What did I mess up? I lost the negative. I mean, I wrote it there and then I didn't carry it through. So that negative needs to stay in there. So that answer is -2 pi. All right, g of 1 would be the integral from 1 to 1. I can stop right there. What's the area under something that has no width? 0. G of 3. I'm guessing it's asking it's asking me all of these because I'll probably need them later. Otherwise, why would they ask me 4 of them? They could get by with 1 or 2. So the integral from 1 to 3. So the area under the graph from 1 to 3. Let's see, that's a triangle. So 1/2 base times height is just 1. So that one's -1. Not because we went backwards, but because the area is under the x-axis. And then g of 4. So the area from 1 to 4. Well, I've already got the area from 1 to 3. That's -1. And then I need to add whatever this last little triangle is here. 1/2 base times height would be 1/2. So -1 plus 1/2. I could leave it like that, but since I've done a few of these already, I'm betting I may need that value later on. So -1/2. Okay with those? That was pretty straightforward. Just plug in the number, find the area. Part B. On what intervals of x is g decreasing? G is decreasing when, what's the rest of that statement? Always and forever. It doesn't matter the context of the problem. G is decreasing when g prime is negative. All right, that statement's always true. So for this particular problem, I need to know something about g prime. Except I don't have g prime. I have g. And I want to get g prime. So let's take a derivative. Well, the derivative, take a derivative of the antiderivative, and then you're like, oh yeah, that's the whole point of this unit, is that the derivative of an antiderivative is back to the original. So g prime is equal to f of x. That's not really the answer to this problem, so I'm not boxing it because it's the answer. I'm boxing it because it's important, and I'll probably need it more later. So most of you are not going to show that middle step, maybe not even show that step because that was given up there. But somewhere you would need to have that written out. You've got to say that somewhere. Okay, so where is g prime negative? That would be wherever f is negative. So f is negative between 1 and 3. So my answer is g is decreasing on 1 to 3. Part C. Find all values of x on the open interval -3 to 4 at which g has a relative minimum. Justify. G has a relative minimum when g prime changes negative to positive. But hey, we already know that g prime is the same as f. So I'm just looking for where f changes negative to positive. So look at the graph. Tell me, where does f change from negative to positive? At x equals 3. Careful, you're not looking at slope. You're just looking at where the value of f changes from negative to positive. Part D. Find g prime at -1. Well, again, we already know that g prime and f are the same thing. So g prime at -1 is the same thing as f of -1. So I just look on my graph. F of -1 is 2. G prime of 2, that's the same thing as f of 2. So I look on my graph and I get -1. In fact, if it does not exist, state why, but it exists everywhere. So that's a little misleading to throw that on there, for this particular problem anyway. Part E. Ooh, the second derivative of g. Well, let's see. I don't know the second derivative of g, but if g prime is equal to f, then g double prime is equal to f prime. Zoom back in here. So that means g double prime of 2 is equal to f prime of 2. What's f prime of 2? Here's my graph of f. What's f prime? So what am I looking at on the graph of f if I want f prime? The slope. So what's the slope of that graph at x equals 2? It's right here. Why is it undefined? There's a cusp there. If it does not exist, state why. So yeah, D and E, cusp. G double prime of 3, that's the same thing as f prime at 3. So again, that's the slope of the graph of f at 3. So here's 3. That slope is equal to 1. So my answer is 1. Find the absolute maximum on the interval. So already I'm thinking ordered table of values here. Absolute maximum value of g. Oops, let's not call that y. Let's call it g because that's what we're looking for. And the value of x at which it occurs. Okay, so I need the y value and the x value for the maximum. Okay, check my endpoints. I also need to include critical points. That would be when g prime equals 0. But g prime is the same as f. Again, that's why I boxed this way back when, because I knew this was going to be like repeatedly important here. So when f equals 0, that's at 1 and at 3. So check my endpoints because it's an absolute and it's interval, so I got to make sure my endpoints are okay. So I need g at all of those, but that's exactly what question A was. So I could just fill in my table. And really, I wouldn't have to redo the table here because all those values are previously stated elsewhere. But I think to best answer the question, I'm going to put them again, or sort of replicate that information here. So again, that's all from part A. All those values just import from part A. Absolute maximum. So the biggest one is, well, they're all negative except for 0. So absolute max of, so what's my answer? What's the absolute max? 1 or 0? 0. The y value is the max. So the absolute max of 0 at x equals, and I guess it's helpful that they ask for both because they kind of give away the game here, the value of x at which it occurs. So that means the maximum isn't the x value, the maximum is the y value. So the max of 0 at x equals 1. Which, kind of pause for a second and look at this picture. Try to think conceptually here. G is how much area is there from 1 to x. So we're adding area as we go. Well, from -3 to 1, we're adding area. From 1 to 3, we're subtracting area. So it makes sense that there'd be a max at 1. We add a little more at the end, but we don't add very much. So the biggest value occurs after we've added all that area at x equals 1. Part G. For what value of x does the graph of G have a point of inflection? So G has a point of inflection when G double prime changes signs. All right, that's always and forever, that's true. Now, we said somewhere that G prime is the same thing as f prime. So I want to know where f prime changes signs. So when I look at that picture, give me a value of x where f prime changes signs. -1. So I'm looking for where the slope of f changes. So right there at -1, and then at x equals 2. So something weird's going on at x equals 2. There's a cusp there, but the slope of f changes signs, so that means there's a point of inflection of G at 2. And part H, write the equation for the line tangent to the graph of G. So that means I need a point and a slope. Slope of G, so G prime at -1. So tangent to the graph of G. So I need a point on G, and then the slope of G. So G of -1, I bet we found that somewhere. Did we? We did not find that anywhere. So I got to find G of -1. Nice, we already did 4 of these. We got to do 1 more. That's another backwards problem, so I'm going to switch it around. -1 to 1. So the area under that curve from -1 to 1, that's a fourth of a circle. 1/4 pi times 4, so that's pi. I'm not sure I needed to do 1/4 pi times 4. I probably could have got it from up here. Right, the whole thing is 2 pi, so half of it's pi. Either way. So my point is -1 pi. G prime at -1. Did I mess something up?
Negative pi?
I did it again. Didn't I do that earlier? I did the negative here, and then I left it off the rest of the way. Thank you. G prime is the same thing as f. So f at -1 is equal to 2. So I've got my point and my slope. So y plus pi equals 2 times x plus 1. Alright, I'm telling you, I've said it before, I'll keep saying it, there's one like number 28 on the test. I just make it nice and clear for you there. There's one like number 28 on the test. Obviously the graph is different, so the numbers are all mixed up, and I think I've already told you there's 5 parts instead of 8, but with 8 parts, we kind of ask everything we could ask, so we can now pick 5 of those things. I mean, obviously we could change it up a little bit. Instead of asking for decreasing, we could ask increasing, and relative min, we could change to relative max, absolute min. So we could change it all up, but the concepts covered in number 28 is definitely one of the free response questions on Wednesday. We'll give you a picture that looks something like that. I mean, probably really close to that, because there's only so many shapes we know the area of, circles and triangles being chief among them. Okay, so I'll post that video, and you can find other answers elsewhere.